Good morning, Netherlands, and 안녕하세요. My name is Chuan Lee. I work for the Netherlands Embassy in Seoul. Today is the last session of the Netherlands Hydrogen webinar this week. For Korean viewers, I'll make a short brief in Korean first. 지금 저희 한국 네덜란드 수소 웨비나를 시청하고 계신 한국 시청자 여러분들께 알려드립니다. 본 행사는 모든 발표가 영어로 진행될 예정이고 발표 중에는 통역을 지원하지 않으니 양해 부탁드립니다. 만약 웨비나 중에 질문이 있으신 분들은 유튜브나 줌 채팅란에 글을 올려주시고 글을 올려주시면 제가 보고 네덜란드 발표자나 다른 참가자들에게 질문을 전달드리도록 하겠습니다. 그리고 B2B 매칭을 원하시는 분들은 유튜브 채널에 있는 B2매치 사이트 등록에 가셔서 기업 정보를 입력하시고 해당 사이트에 통한 미팅을 신청하시면 됩니다. 현재 많은 미팅이 벌써 요청되고 있으니 로그인 하셔서 확인해 주시기 바랍니다. 그리고 다음 주 수요일부터 금요일 사이에 코엑스 홀 A에서 H2 월드가 인터배터리 행사와 함께 있을 예정인데 저희 대사관도 부스 참여를 할 예정입니다. 이때 부스를 방문해 주시면 또 많은 정보를 얻어가실 수 있을 것 같습니다. Okay, back to English. This webinar is streaming through the Zoom and YouTube channel. Today will be the last session of the webinar, but there will be still be other programs like business matchmaking between Korea and Dutch companies through a B2Match site. The link is on YouTube website, so you can click on it, and also on our social media channels. The other events are we are planning this next week is H2 World Exhibition at COEX. The embassy will present Dutch hydrogen businesses there from Wednesday to Friday next week. You can visit us and discuss further at the booth. Today's topic is about developing a hydrogen supply chain, such as production, storage, and transport, which are the greatest hurdle for hydrogen roadmap in Korea. In Korea, hydrogen utilization, such as hydrogen vehicle or stationary power stations, stationary power generation is relatively well developed. But the upstreaming technology is less commercialized. I'm pleased to have Mr. Charlie Moon here with us today from Elchemtech. The company is one of the few companies which works on this upstream matter. We will hear from him after all the Dutch speakers. For online presenters today, we'll show the slide from the operator in Korea, so please let us know when you want to flip the slide. And each one have 10 minutes to pitching time. We'll inform you the time through your Zoom chatting. The question and discussion will be allowed after we finish all the speakers. Please write us a question or comments through Zoom or YouTube chat. I'll relay them during the discussion session. So without further ado, let's start with our first speaker, Mr. Robert Jan Berg from Soluforce. Online stage is yours.
Hello everyone, and a warm annyeong haseyo to everybody in Korea. I'm privileged and very pleased to give you a short presentation about our company. My name is Robert Jan Berg. I'm the Managing Director of Soluforce. Next slide, please. Next slide. Hello, I miss you. Soluforce. I think something goes wrong. Oh yeah. Can we go one slide back, please? I miss you. Yes. Soluforce, what we do, we are a technology supplier. Our mission is to revolutionize the way energy is transported. And we do that by offering solutions that in which you can transport energy. We make reinforced thermoplastic. We produce a full non-metallic pipeline system that allows you flow lines, water injection, gas transport, biogas or hydrogen through pipeline. Next slide, please. The history of Soluforce. The product Soluforce itself originated from an R&D project that was a joint combination between Shell, Teijin and AkzoNobel. And it was initially meant to find a corrosion-resistant product for the oil and gas industry. That was the starting point of Soluforce. That is now more than 20 years ago. And in the meantime, we have developed a product that complies and even sets industry standards, international industry standards for the type of product that we are providing. And recently we have already sold over more than 3,500 kilometers of our pipe worldwide for various applications for energy transport. We're part of an Austrian-based company, which is stock listed in Austria. It's called Wienerberger, and that is our main account holder. Next one. As we said, our product can be used in various ways of transporting. From right to left, you can see a couple of pictures over there. You can see multiple transportation lines for flow lines in oil and gas in the desert. You can see also installations for remote areas in Colombia and Indonesia, where we are crossing forests. And on the left side, you can also see offshore applications for flow line injections and the things like that. What is the general idea behind it? Our product is extremely easy to install, and we can come in various locations will not be able to reach. Then I want to bring you to the hydrogen specific applications of Soluforce. So next slide. So what did we do for hydrogen? Just shy of 2 years ago, one of the ports in the Netherlands, Groningen Seaports, approached us with a request if we could develop for them a specific hydrogen pipeline. They had the intention to install the first backbone of hydrogen in the Netherlands, and they wanted to have a fully non-metallic product for that. So what we did, together with one of the independent third-party institutes in the Netherlands, which is called Kiwa, we did extensive testing on our pipe. It was testing of about 14 months, where we tested the permeability of our pipe, but also the compatibility of all the components of our pipe against hydrogen, which ultimately concluded after 14 months of testing that we've got a product which is unique in the world, as I may say, and that is fully tested and modified for hydrogen applications up to 100% hydrogen transport. Next slide, please. How does this pipe look like? The pipe consists of a leak-tight, non-corrosive PE inner liner. Then it has got an aluminium anti-permeation layer. Then it has got a 2-layer of reinforcement, that is aramid reinforcement, that is being produced by our light cover of PE, which can be, in case you put it on the surface, has got a UV resistance and make sure that your pipe will remain at ambient temperature. Next slide, please. Again, what are the benefits and the key elements of our pipe? the way we also want to emphasize for the hydrogen world. Our calls are coming, as you can see, on, our product is coming on calls of 400 meter. They are easy to transport. They are easy to transport not only internationally, but also locally. You can see in one of the pictures, you can just use an excavator, have a very easy trailer behind it, and you can start installing our pipe. That makes it very easy and accessible to install our product everywhere. It makes it flexible. The product is reusable. And most of all, it makes sure that the timeline of a project is much less than what it normally is. Then the next slide indeed, the timeline of Soluforce. So as I said, mid of June 2019, we certified our pipes fully for the hydrotight applications. You can see also on the right that at the same time at the Stork inauguration party, our king also acknowledged our product. We hope by end of this year to have this first hydrogen installation in the northern part of the Netherlands. And we would be pleased to continue with all multiple projects, hydrogen projects in future after that. Again, the stakeholders in the development of this product are Groningen Seaports, as I mentioned, also Kiwa, our aramid supplier Tejin, also Professor Ad van Wijk, who you can see on the right below corner that has put his signature on our certificate. And we hope that in the future, many more parties can be a stakeholder of our product. What I do like to say is we are there. We have a product that can easily and readily transport hydrogen up to 100% of hydrogen mix at the moment. We're looking forward to bring our technology to every part of the world, also to Korea. And what we're looking for is one, projects in Korea that have a request for hydrogen transport, but we also look for partners to develop our product further or potential agents to help us steer and understand the market in Korea. That was my presentation, and I thank you for listening, and 감사합니다.
Thank you, Robert. And the next speaker is Mr. Harold Merikens from HyGear. Did I pronounce you right?
Yes, that is somewhat correct. Thank you very much for the introduction. I'm Gerard Merkens, account manager for HyGear in Asia. I'm currently based in Singapore. And I want to thank you all for the opportunity to present HyGear to you today and the services we provide. Next slide, please. So HyGear is a company established in 2002. And the CEO of the company at that time had the vision to create hydrogen, small-scale hydrogen stations to generate hydrogen for the fuel cell mobility industry. As we all know, back then the fuel cell mobility wasn't as developed as it is today, with the recent developments in mobility and the trucks and the cars. So we basically turned to the industry. So that's where we have our most reference today. We have 88 employees, 10 of them which are located in the office in Singapore. And up to date, we have over 50 systems installation, 50 systems operational worldwide. And that really varies from America to Europe, but also in Asia and Bangladesh. And last year, we secured our first reference project in South Korea, which is of course very exciting. And this year, that project will be commissioned. As mentioned, one slide back, please. So as mentioned, we are mainly active in the industry. In the float glass and in the metal industry, you see that they need a 24/7 supply of hydrogen gas. And there we always use a combination in a method of supply. So we have the on-site hydrogen generation, either through steam methane reforming or electrolysis. And apart from that, we also have multiple technologies available for the recovery and purification of the gases. And nowadays you see more interest, of course, in the fuel cell mobility industry for on-site generation for fueling stations. Next slide, please. So what are the technologies that we have? The HyGen is our core technology. That's the steam methane reformer, which is built in a 20 or 40 foot container, which is able to produce hydrogen gas from natural gas. Apart from that, we also have the HyGen E, which is an alkaline electrolyzer, also comes in a 40 foot container. And specifically for the glass and in the metal industry, we have developed the HyREC, which is a recovery technology that is able to capture the spent gases that they use in their process, purify them up to the required standards, and then feed it back into the process. And for other applications, we have also the HyPure, which is able to purify hydrogen gas up to higher purities. Next slide, please. So what is our distinct advantage? In the traditional supply method, you see that you have a centralized production location for the hydrogen gas, and then the gas is compressed into trailers and transported via road transportation. And one of the benefits that you have with on-site generation is that you minimize the amount of truck movements. The systems are completely autonomous, so you also have less risk due to human interaction. And because you minimize the amount of truck movements, you also have a reduction in CO2 emissions. Apart from that, we do, however, own our own truck operated fleet. That is so we can secure 100% supply reliability to our customers. So let's say if you have a generator on your own site, we would also include a tube trailer supply to really secure that 100% supply. Next slide, please. So I just want to briefly touch on the HyGen generation technology. As mentioned, they're completely autonomous systems built in 20 or 40 foot containers. And the first system is placed in 2010 and still operational. Next slide, please. So for example, this is a HyGen 50 system, and everything from natural gas inlet until hydrogen gas outlet is included in the system. So in brief, that's the desulfurization of the natural gas, the hydrogen production, the reformer, and the hydrogen purification step. Additional equipment to compress and store the gas are not included in the system, so that will be outside of the container. But everything regarding the production and purification is included. Next slide, please. And we have three models available. So the HyGen 50, able to produce 50 or 47 normal cubes an hour. That is roughly 100 kilograms a day. The HyGen 100, which is roughly 94 normal cubes an hour, able to produce 200 kilograms a day. And the HyGear 150, which is able to produce roughly 300 kilograms per day. And nowadays, we indeed see the increased demand for fueling stations. So it's ideal to have one or two systems. You can combine them. You can install them in cascade to secure that supply for the fueling stations. One main advantage of these small-scale on-site generators is the flexibility. Whereas normally you cannot scale down the systems too much because it will cause wear and tear and stress on your materials, on your metals inside the system. Our system can really scale down to 10% of its maximum output. So for example, for fueling stations, of course, you don't have a constant flow or a constant demand. So the system can actually can read what the demand is and scale its production to the requirements. Next slide, please. So as mentioned, we have our first reference in South Korea. There, the hydrogen gas that is produced will be used for the stationary power generation, but also for fuel cell vehicles. Next slide, please. And apart from South Korea, we have multiple references, as mentioned earlier, all over the world. We have a really strong R&D backbone because we want to develop new products, but also improve the products that we already brought to market. So we work together with various companies to conduct those researches. And in this reference list, you can indeed see there are glass companies there, but also industrial gas companies who purchase the system just so they can have a dedicated on-site generation of hydrogen gas that they can then compress into cylinders and sell off as their own revenue stream. Next slide, please. So I'll just go through some of the references. If the time is up, please, we'll go to the next speaker. But for example, this is a fueling station in the Netherlands, in Arnhem, where we have our own hydrogen fuel cell car. And I was fortunate enough earlier this year to drive around in it, which is, of course, a real experience. It's similar as an electric car. But we have developed our own fueling station, and in the back on our own premises, we have a dedicated HyGen to produce the hydrogen gas for the station. And right now, the station is also accessible to the public. So if people have bought a fuel cell vehicle or a truck or a bus, they're able to charge their vehicle at our station. Next slide, please. Another example for the fuel cell mobility industry. This is in America. Actually, at Walmart, they have converted all of their forklift trucks from diesel, petrol to hydrogen fuel cell forklift trucks. For that, they need the on-site generation, including on-site storage for those trucks. Next slide, please. And this is in Philips in Belgium, the Lumilets production facility. Here we have a combination of supply. So this is one of our supply methods where we offer gas as a service. So we have the on-site generation for the generation of hydrogen gas. But apart from that, we also have the tube trailer as additional supply in case to cater for peak demands. But also in case one of the generators fails, you do have the hydrogen that is required for your process. Next slide, please. This is an industrial gas company in Americas. They used to buy their hydrogen gas from another industrial gas company or import it for a very high price. And now they have a solution for their capacity to generate the gas on site and sell it to their customers. Next slide, please. The containerized systems can also be placed indoors. The only remark is that you have to connect the valves from the vent to the top of the roof, and then it's completely okay to install the systems indoors, and that is no issue. Next slide, please. And now to go show you two extremes. This is in Germany in the winter, where the systems are operating for a metal factory, and that is also no issue. And then next slide, please. And this is going from the freezing cold to the hotness in the desert, not really the desert, I would say. But this is in Turkey for a float glass line where we supply two hydrogen 50 systems that generate the hydrogen 24/7 for their facilities. Next slide, please. So this is in brief about HyGear. As mentioned, we are an industrial gas supplier by methods of on-site generation. And with the customer, we always try to find out what is the best method of supply. Is it a combination indeed of on-site generation or trucked-in supply? And we have different options available in terms of gas as a service or buying the equipment from us. So we are always open for discussions to see what the best possible solution is for you. So I want to thank you. Have a very nice mission ahead, and over to you, Juan. Thank you.
Thank you, Gerard. And we'll move to the next speaker from Northern Netherlands, Willem Hazenberg from Stork.
Good morning, everybody in Korea. Couldn't make it to make the travel. Next slide, please. I do a lot of things, a lot involved in hydrogen, but I'm a senior consultant in Stork Asset Management Technology. Next slide, please. Stork, we are a global company. We have offices from Fluor in Seoul and in Tokyo. We have about 48,000 people and about 18,000 at Stork itself. Next slide, please. What's the difference between two companies? Fluor is a company really in designing equipment, really in the front end. Stork is more a construction company, and the combined effort is really you can take the entire value chain as a client. Next slide, please. This you can start the video, please, for me. This show you a little bit about our history, what we are doing.
During the Industrial Revolution in the 1800s, a smart entrepreneur from the east of the Netherlands, Charles T. Stork, saw the potential of new technology. Full steam ahead, by 1868, he and his brother had opened a factory in Hengelo. Within 5 years, Stork built its 100th steam engine. 25 years later, we delivered the 1000th engine. One system per week for clients worldwide. Our turbines, pumps and engines began powering industries and driving economic growth. Stork's products received top recognition. We won gold for our horizontal compound steam engine at the 1878 World Expo in Paris. And we were certainly in good company. Along with product innovations came social innovation. Stork cared about the well-being of its people, recognizing that they were key to success and believed in sharing prosperity. As our products spread throughout the world, our company also grew, spreading its wings to the Far East and the Far West. Stork colleagues began traveling widely to support their products. The products of Stork directly impacted countries and communities. By the 1950s, more than 200 pumping stations were powered by Stork engines and pumps to keep the Netherlands dry. Some are still in use today. The world's most powerful diesel marine engines were built by us in 1975. After years of engineering and collaborating with industry peers, as we continued to grow and diversify, we acquired companies with specialty expertise, merged with others, and took on joint projects. In 2007, with a workforce of more than 8,000, we shifted our focus to industrial maintenance services, while keeping select fabrication capability. Within 10 years, our workforce had more than doubled. First adding businesses from South America to Australia, and then joining Fluor. We are now 18,000 people strong. Stork is its people. We are one team, working together, connecting and engaging, and sharing expertise around the world. We work under challenging conditions, with high-pressure equipment and in tight situations. Therefore, safety is at the heart of everything we do, and has been for more than a century. Backed by the right training, the right preparation, and the right mindset, we make our solutions work for our clients and value the communities in which we work. Innovation is still in our DNA. We drive new technology solutions and will always look for a better way. Stork is taking on the challenge for the next 150 years.
Next slide. This was one of our latest big projects in the Holland. This was a project for Shell NAM. It's about a 700 million project. This was the entire erection of this site. Also, we get yesterday the award for 3 years maintenance for Shell Esso for this site. Also, but what we are seeing is this old world will disappear, the oil and gas world. This was our core business. Also, that was the reason that we say, okay, we go for the new energy, new transition. Also, that's the way we came from. Next slide, please. Also, our ambition is to be the industry reference in the field of hydrogen for consultancy, engineering, and project management. Next slide, please. Also, what we did, we started an organization, we call it HydroGreen. And that was, we all talk about hydrogen, we didn't see projects. Also, we really start to build value chains. That started by 22 people. This moment is more than 500 people, 180 people of organization involved. Stork is leading this group as chairman. Next slide. Also, Stork is seen in the industry as a hydrogen community. Also, you see our presentations at the World Forum in Germany and now in Korea. Next slide, please. Also, one of the things that we say from cry to concrete, you just have a plan, like on the left corner on top, it was just a sheet. On the end of it is the opening of the king, of the presentation of the hydrogen city, what will be tomorrow presented in the Japan meeting. Next one. And this is the hydrogen city. where we will have started by 80 houses and then go to 427 houses on hydrogen. We developed for this project a hydrogen burner. That's a new developing. The testing is finished this month. It will be operational in 2022. Next one. This was organization. Also, we need not only look to the technical part, but also to social acceptance, legal frameworks, business cases, implementation. All blue parts on this sheet was Stork involved. And Stork was overall responsible for the entire project and also the consortium lead. Next one. Another thing we did for the European Union was developing a roadmap. We call it the green electrons to green hydrogens. The links are below. Also, you can get the entire report there. Next slide, please. There are multiple work packages, but the main question was, what is the roadmap? And what's the path we have to go there? All other parts are building up. This is a public report on ResearchGate, also you can access it. Next slide. Other things is a consortium that we are working is, you see in the value chain where Stork and Fluor is fitting in the other parties. I just take them out for the moment. Next slide, please. Also Stork, we think we also need an educated people on hydrogen. Also, we were the founding father of the GAS 2.0 educations for more training, more than 3,000 people on sustainable gases. And hydrogen is one of them. Also, we're starting this education for 2 years ago for technicians. Next slide, please. Another project we're involved in is the Heaven project. That's an investment program for 2.8 billion in the Northern Netherlands. It's combining 31 projects. The whole Veen case is one of these slides, of one of these projects. Next slide, please. This is the Northern Hub in Netherlands, and you can see the yellow arrows are projects where the Stork is involved. That was in part in solar, that was in the HyStork project, the industry, the houses. Next slide, please. This was the opening of the HyStork installation. It's our biggest one, the 1 megawatt. Stork did all the welding work there, and that's on top you see me with the king to present the Hydrogen City project there. Next slide, please. Another small project was early mentioned, that just the filling station at AkzoNobel. Also, we Stork did all the integration work between the pit point and the AkzoNobel site for the hydrogen installation there. Next slide, please. Another project, this is more the old-fashioned hydrogen, but it's a PSA plant, and we did all the mechanical work, instrumentation work, and the work preparation and the commissioning of this project. Next slide, please. Another big project is a 100 million revamp of a biomethanol plant. This is what you can, the gray hydrogen, but still we have almost 60-year experience in hydrogen and to handle it. Next slide, please. I see we did a lot of different services like mechanical service, boiler services. For example, the boiler services, we developed the hydrogen burner of one of our consortium partners, but he didn't have the know about seals. But our guys from the boiler services, the big ones, also we talk 10,000 is a small one, has the knowledge, and we transfer the knowledge to the other company, then they use in different market. But our knowledge about hydrogen. Next slide, please. A very interesting project that we are doing at the moment in California is we call it Waste to Hydrogen project. It's a plasma. It's a pilot project, but it's 30,000 tons a year. So that's a really big project already compared to the 1 megawatt size. And the target price is €2. I think there will be next week or the week after the more public announcement on it, but this is already there. But there's a big agreement already around. Next slide. Another project that we are doing in Stork, you say we have a lot of boilers in the company. We develop a boiler on hydrogen, but also on hydrogen and oxygen. This means we can go up to 3,000 degrees, and we develop it in Netherlands in our Hengelo area. Next slide, please. Other project that we are working on And I see the lady is also involved online. It's a zero emission power box solution. This is a container that we can put behind the train, and we will power the train on that way. And we're also looking at this solution now for other applications where we need zero emission solutions. Next one. Another project that's starting this month is on the entrance site. This is the education site for the applied engineering. And there we will build a 200 bar, 50 bar, 8 bar hydrogen net. And in January, we will start there by a 1 megawatt test center building. Next slide, please. I see in the bottom, you see our entire scope. Also, we can really do the master planning, the engineering, the procurement, the fabrication, also an entire value chain or any part between there. About blue hydrogen, Fluor has the light sensor of the carbon capture recovery technology. Also, we have it in-house. Also, when you have a gray hydrogen plant and you want to make it blue, we have the technology in-house. We do it at the moment for Shell in Canada. Next slide, please. You see, this is the commissioning phase. It was one of the plants, and you see a lot of information there because you're really on top. The business, you have an idea like I want so many tons, and you go to the entire phase into up to smallest detail, and finally you get delivery. This is our process steps, how we are doing it. Next slide, please. I think I make it in time. So one of the most important things in our company is safety, and then safety I think is even more important in hydrogen. Then nothing will kill hydrogen more than just a safety incident. Also, our core business, but that was already our background from oil and gas, is safety is first always. Thank you for the opportunity to give the presentation. Next slide. I think I'm finished.
Okay. Okay, thank you, Willem. Very impressive projects. Your portfolio is quite huge.
Yeah.
No. Next speaker is Mr. Max Middelman from HyET Hydrogen.
Yeah, thank you for having me. I'm Max Middelman, Business Development Manager at HyET Hydrogen. We are a startup based in the Netherlands, in Arnhem, physically next to HyGear. They are our neighbors. Next slide, please. We are part of the HyET group, which consists of 3 companies. The first company is HyET Solar, which makes thin film flexible solar modules that can be applied onto all kinds of roofing surfaces. The second company is HyET Hydrogen, and that's the one I'm talking about today. Next slide. Next slide. What we do is electrochemical hydrogen compression, which is compression of hydrogen in a way that's quite familiar, quite the same as how fuel cells or electrolyzers work. What we do is low pressure hydrogen comes into our stack. We split it up into protons and electrons. Protons can go through the proton exchange membrane, and the electrons can go past. On the other side, they form hydrogen again, and because we keep the flow constant, we can build up pressure. These membranes are put into cells, these cells are put into stacks, and stacks can be put in systems. And therefore we can scale up our system size modular, and that way we can customize our product to the needs of the customer. The upsides of this is that you have isothermal compression, so we don't have any moving parts. The only energy you need is to actually move the protons. It's single stage compression, so you can go from low pressure hydrogen up until even above 1,000 bars without any moving parts in just one flow. You can turn the system on and off to whatever extent you need, and you can even turn up the capacity a little bit if needed, just by applying a higher amperage over the membranes. Yeah, you can use it in a parallel connection, so you can it's a scalable solution where you can just add more stacks to the system to increase your capacity. Next slide, please. So if you compare it to regular mechanical compressors, you see a lot of differences. The first is obviously the maintenance. So usually the mechanical compressors have all these moving parts, and the compressors are initially not really built for hydrogen itself, which eventually causes them to break down quite easily. We don't have that. Our materials and our technology is especially developed for hydrogen, and therefore we can assure the same lifetimes as fuel cells or electrolyzers have. But we don't have any oxygen, so we don't have the risks of that. Because we have a scalable solution, we can switch out the cells or stacks if we need to. We can monitor each cell from a distance. So if we see that one cell or one stack is ready for replacement, we can just switch it off while the rest of the system is running. So therefore we can assure an availability of the compression system of 99% or more. We have a relatively low energy consumption. As I explained earlier, it's an isothermal compression system, which only uses the energy to compress and not to move or whatever. So you don't really have heat or whatever that occurs. And therefore, eventually your TCO, your total cost of ownership of the compressor, is really low in terms of dollars per kilogram of hydrogen that you compress. Next slide, please. So over the years, we've done a lot of developments. At first, in 2010, we started with a single cell system, which could compress the really small amounts of hydrogen to high pressures. We went to bigger stacks with more cells, and what we are at right now is scaling up our HES 100, which is 100 square centimeters per cell, up to the HES 500, which is the next stack configuration, which can do 50 kilograms a day per stack of compression. And if we make this in a modular system, yeah, you can scale up your compression capacity to whatever size you need. But that also lowers the total price of your system to prices around 300 to 500 euros per kilogram per day for your compression, and that's a good price for compression, and lower than the regular mechanical compressors, especially in the smaller quantities. Next slide, please. So over the years, we have done some projects. At first, we started with a small cabinet to refuel drones in the US, where we did 2 kilograms a day. It's a portable system that's still running there. We also did some 10 kilogram a day cabinets for higher pressures, so to refuel cars, for instance, at 875 bars. The container you see in the middle is the one that we use in a project with HyGear as well, for the hydrogen refueling station. It was a container that did 120 kilograms a day for the refueling station at their site, and we're at the moment scaling it up to bigger capacities with the HES 500. On the right side, you see the stack-in-a-box concept for the larger containerized systems, where you see the box, which contains one stack with its own power supply, nitrogen blanket, and all the equipment that's needed, and the rest is the balance of system. So we can, generally scale up the system per box. And this can scale up till 2,000 kilograms a day, or whatever is needed. Next slide, please. So this is what I explained earlier, the scale up of the system, where we did 0.01 actually kilograms a day at the first R&D instrument, and where we go to systems of 2,000 kilograms a day next year, and even bigger are requested at the moment. Next slide, please. This is actually the project that we did with HyGear. You see that the stacks are put into these racks. After that, we did an improvement for the stack-in-a-box concept. So we are constantly learning how to improve our systems. Yeah, we're scaling up the amperage per square centimeter as well for the cells, which eventually leads to a higher flow rate. Next slide, please. For reliability, we do some testing, of course, and what we do is switching the compressor on and off constantly for a couple of hundred or a couple of thousand times. And what you usually would see is that you see some degradation, but we're trying to level that out. And what you see in these graphs is that we're switching it on and off constantly, and that the performance stays the same. With these start-stop cycles, of course, we're a startup. We're not around for this long, but with these numbers, we can. We have a good indication that we can guarantee the lifetime of 40,000 hours of operation. Next slide, please. And that was my presentation. Thank you for having me, and thank you for your interest in our product. And I hope to be able to answer all your questions later on. Thank you.
Okay, thank you, Max. So we have a final speaker. We will now hear from Mr. Charlie Moon from Elchemtech.
Hello, everyone. This is Charlie Moon of Elchemtech. First of all, I would like to thank the Dutch Embassy for having me here and give a presentation. And today, I want to talk about how the current development of green hydrogen is in Korea. So first one would be on green hydrogen in Korea, and the second one would be what Elchemtech is doing to do with green hydrogen here. So why hydrogen is a must in Korea? So the reason is that Korea has a low energy self-sufficiency, high emission of CO2 carbon dioxide, and unstable renewable energy due to 30-20 policies. So to remove those problems, that hydrogen is a must, especially with the green hydrogen using an electrolyzer. I want to talk to you about the government policies that's been released. So it started with a 30-20 policy, which is to have 20% of power generation from renewable energy by 2030. Then it was transferred to the hydrogen economy roadmap. Here you'll be able to see the amount of hydrogen or they want to produce, or the price, or which kind of methods they'll be using to produce hydrogen. The reason why I added some additional information here regarding electrolyzer is because everything in the future, now the Korean government is focusing on producing hydrogen using SMR methods, but eventually it will transfer to green hydrogen using electrolyzers. So this is the latest policies that's been released. It's about, it's the Korean New Deal. It's to transform the economy from a fast followers to a leader, from a carbon-dependent economy to a green economy, and with the society going to a more inclusive one. I just picked out the main issues regarding the hydrogen. There are two. One of them will be green energy. So it will be basically from the fossil fuel to the renewable-based economy and the eco-friendly mobility for the future. So it will be fossil fuel-based transportation to electricity or hydrogen mobility. The biggest target would be for green energy is that not only they're trying to improve the amount of renewable energy generation, but they're also trying to build hydrogen cities. The three cities are released. They're already released, and the extra cities will be chosen later on. But altogether, they'll have 6 cities in Korea that's to do with using just hydrogen or maximizing the hydrogen production. For the eco-friendly mobility projects, I'm sure that you guys have seen this number a lot. It's based on the overall cars there, especially with the fuel cell vehicles. Korean government want to reach around 200,000 FCVs by 2025. And not only that, they want to build a cumulative number up to 450 refueling stations. And they also want to have hydrogen production near station They didn't really emphasize on on-site hydrogen generation, but we expect that it will be somewhere very close by to produce close production of hydrogen. Because I want to talk about green hydrogen or electrolyzer, I want to talk about the power-to-gas projects that's being in process in Korea. So altogether, up to now, there are 6 government-funded projects. Now you can see that most of it started from 2015, and it's gradually the size of the electrolyzer capacity has been increasing from 200 kilowatts system to megawatt systems now. And one of the hydrogen cities, which is called Saemangum, will have a hydrogen production up to 100 megawatt using the electrolyzer there. And I want to talk about Elchemtech and what we're doing at the moment. So Elchemtech's been around since 2002, and we've been focusing on developing PEM water electrolyzers since 2003. And Elchemtech is the only company in Korea to provide megawatt scale PEM electrolyzers at the moment. And we have very strong value chain. So we start from the catalyst to the MEAs to the electrolyzers and the systems. So you can see, if you can see on the pictures there, that is our 0.5 megawatt stack. So it's in operation at the moment at one of our the demo sites we have. And this is the projects projects that we're doing at the moment. Mainly, most of them are funded, government funded, or government company funded projects. But we're also looking into a variety of options, including feasibility studies to produce methanol, green hydrogen, and hydrogen plants. And this is just like our roadmap of how we want to develop our electrolyzer. So at the moment, we're at the scale of 1 megawatt, but by 2025, we want to have a 5 megawatts electrolyzer. And we want to have that system stacks integrated up to 100 megawatts. And we're hoping to increase our annual production by 300 megawatts by 2024. And if the mass production game goes on, we were hoping to reduce the price of the electrolyzer up to 500 euros per kilowatt. And that will be it. I want to have very short. So thank you for having me once again, and thank you very much.
Okay, thank you, Mr. Moon. Now all the presentation for today is done. We'll have discussion session until 7 p.m. Dutch time, noon. So please write your question or comment on YouTube chat or Zoom chat so that I can read it from the tab. And 우리말로 이제 줌이나 아니면 유튜브의 채팅창에 글을 올려주시면은 제가 질문을 영어로 좀 전달하도록 하겠습니다. So I think there were some questions. The first question is to HyGear. Can you please elaborate more on the project in Korea? I think I heard that the customer want to keep it as bit low key, but if you can elaborate more.
Yeah, sure. That is no issue. Indeed, I cannot name the specific customer or the location, but the hydrogen will be produced through the SMR technology, through the HyGen systems. And the hydrogen that is produced will be used for stationary fuel cell to generate power. But apart from that, they also want to have a solution on site at their facilities for hydrogen fuel cell vehicles. So the hydrogen that is produced will partly also be used to fill up the fuel cell vehicles at their facilities. And that's all.
Okay, thank you.
Thank you.
And our question is to Elchemtech. Do you have experience with working with a foreign company? Are you interested in cooperating with the Dutch companies? If so, what type of cooperation are you interested in? I think the question is about maybe could be R&D project or pilot project or even commercial purchase project.
Well, I think everything is to do with both companies having a win-win situation. So we're open to variety of options. We are still, as I mentioned before, we are also talking with Canadian and Chilean companies. So anything's open. So if you have any kind of like ideas on a corporation, please feel free to contact me.
And is there any question from the speakers today?
No.
Okay. Then I have some questions. Maybe to Soluforce. In Korea, I think, as far as I know, the Korean regulation is allowing only steel pipelines to transport even natural gas. And do you see this kind of a polymer composite pipe to replace like small portion of this market by opening some new sort of application, or do you think this will replace some of the main pipelines in the future?
That's a good question. Thanks for that. Of course, what is important, for what you said, is a challenge for Korea. But by having a status quo at the moment doesn't mean that things will not change in the future. And we are especially looking at all the areas in the world where we do apply our pipeline for gas transport, for hydrogen transport, and the easiness or challenges in which we can change the regulations, that gives us comfort for the future. But that, of course, all depends on the discussion that we need to have, or that the industry needs to have in Korea with the regulators. So indeed, it's a good question. But like I said, yeah, if you would ask Mr. Ford back many years ago what people would like to have, then they would say faster horses. And then we would never have a car. So if we say, well, we have to stick with steel pipes, then we never change the supply chain.
Right.
And we are comfortable that we will have add value to the future supply chain with our product.
Yeah,
I can say also something to that when you want.
Okay.
I know the business case from Delcel area, and the steel pipe was, let's say, too expensive to make a case. And the Soluforce was a way to make it cheaper, let's say, in that way. I'm also part of the Dutch standardization platform, and you can do a lot of discussion about, okay, how should it be? At a certain moment, you have to do certain tests, like they did at Tira. Then we will do certain projects. We will learn from this project, and that will be finalized in standardizations. And I understand yesterday that you have also some economical free zones there, and you could test it equipment there. Yep. We have also a project in Delcel running that's a multiple kilometer pipelining on hydrogen by this solution. Also, the experience we will build up, and when it is much easier, I know some people said, hey, it's not so good for Stork, then we also have all the welders. And then but also we have a very good fiber group also can work on that. But it's a very nice concept to get a low-cost solution for transport hydrogen.
Thanks for your additions, Willem. Much appreciated.
Yeah, in Korea, maybe yesterday's session, maybe if some of you may have joined. Kotra presented about this regulatory free zone in Ulsan. That is actually this is kind of thing that they want to do the pilot. So beside the regulation, that there will be a lot of the new technologies that they need to be validated in order to get certified in Korea. So I think that could be a good place to start for, I think, Soluforce for your business, maybe because there is still a strict restriction by the Korean government law.
Yep.
Okay, and I'm looking for, is there any other questions? There's another question to Elchemtech.
Yeah.
Okay, what is the main driver for cost reduction when scaling up the electrolytic capacity? Is it industrializing the assembly line, technology improvement or usage of less scarce material necessary or other?
I think it's a mixture of all of them. At the moment, most of especially in Korea, there wasn't a market for PEM water electrolyzers. So everything is like single control, or like in a way it can be handmade. But in a way, if we increase the production rate, that will be meaning mass production, which will obviously lower the cost of the overall price. Also, for the PEM water electrolyzers, one of the issues would be the catalyst or the membranes. We're always looking for a variety of ways to lower the overall usage of those. And what else was it? Can I just see that?
Assembly or
yeah. So and also the final will be the technology improvements. Everything will be about how much you can produce with a single electrolyte stack, as that will be our key issue there. So I think all of them matters a lot.
Yeah.
Okay. I hope that answers the question.
Yeah. Maybe then here comes also the question for both, I think, Elchemtech and also HyET, because you're using the PEM technology base. And for operational cost perspective, how this PEM polymer membranes can be competitive against your other technologies. Maybe Max, you can address some of these challenges.
Well, basically, the compressor itself must compete, of course, with mechanical compressors, which is a total different technology. Therefore, especially for lower capacities, it's not too difficult to compete with mechanical compressors, especially on the maintenance. We don't really have any maintenance, so your operational costs are very low, especially if you see how many times there's maintenance or specialized people that need to work on these compressors, and also on the energy consumption. For the scaling up to the HS 500, we're aiming for an energy consumption of less than 3 kilowatt hours per kilogram of hydrogen, which is eventually really efficient for the compression. So yeah, basically for the operational costs, we're already cheaper than mechanical compressors.
Okay.
For the electrolyzers, I think everything would be on how much operation cost is there to produce hydrogen, and it's not really everything is based on how much electricity is used. But our target would be to use less electricity, and obviously the advantages of PEM water electrolyzers is the maintenance. The price is very low for that, and one of them is the operation time, especially for the electrolyzers, and to produce green hydrogen at a cheap price. I think we need to have some amount of operation time, and we assume that if there's if the renewable energy produces electricity for about 3,000 or 4,000 hours, then we will have a competitiveness against the SMRs. I don't know what Jared thinks, but in a way that can be possible. So I think, yep, I hope that answers the question. Yeah.
So do you think this SMR, also the Stork talk about this plasma technology to produce hydrogen? There's alkaline, PEM, electrolyzer. So do you think this will coexist for certain period? Or do you think eventually there will be a superior technology which can replace everything?
I don't know, but for now, I think all the technologies will coexist to produce. The main issue is not just to dominate, but to produce hydrogen in the variety of methods. So it won't be a dominated thing. But I don't know about the future. There might be a new technology that pops up that dominates everything. But for now, it will be together in more.
Okay, might be fair to also have a chance. for HyGear to speak about that as well?
Yeah, I totally agree. I think it will be a combination of different technologies that will be required in the upcoming years. Because of course, hydrogen is a way to go net zero through electrolysis, through biomethane or other sources. But right now, we need to create the infrastructure for the hydrogen. And as many talked before as well, it's a bit of a chicken and the egg situation. As long as you don't have a hydrogen supply, the consumers will not be able to convert to hydrogen fuel cell vehicles or other sources. So you will need multiple technologies to supply that hydrogen. So I think all of the technologies, electrolysis or SMR or other pyrolysis or plasma technologies will play a role to create that demand.
Okay, thank you. And
that's also my feeling. It's also depending about the size of systems. When you really want to have net frequency, then use PEM is a little bit better than alkaline.
Yep.
Then we're looking at the moment for big installations, the 50 or 100 megawatts project that we have. This is more alkaline at this moment. PEM is more small. Also, it's depending. What we also see, how do you build your cash flow?
No.
Let's say the project we have in California, they have a lot of waste that was, I understand, previously done sent to China. They didn't want it more there. Also, then now they get some money to use the waste and to make hydrogen for that. This is a pilot, but this makes it very interesting for other markets. Also, it's depending on what is the local situation and how do you embed it in a total package. I mean, the PEM is you need less space and it's easy maybe to operate.
Yep.
But some companies like Nourion has a lot of experience in chemical electrochemicals. Also, they also prefer to the alkaline technology.
Mm-hmm.
Also, we need all systems to grow up and to go to speed up.
Sure. Yeah. And I have also a question about these refueling station that's run by HyGear in Arnhem. I've been to Arnhem, I think, in November, and I saw this refueling station outside of this your company. Is that the one that you are operating? And
yes.
Also, this question may be related to today's announcement in Korean government. They announced that they will make a special purpose company to establish the refueling station for commercial hydrogen vehicles like hydrogen trucks and buses. I think that definitely needs a sort of different technology, or I think it may require on-site production as well, because these cars need a lot of hydrogen than the smaller vehicles. So, what's your take on these the work you've done with this station, and what's your sort of expectation how this will develop?
You're totally right that the station is now located at the site of our facilities. It's incorporated with a regular fueling station, a gasoline fueling station from Shell. And there's been made 2 different dispensers for 350 and a 700 bar dispensing for cars, but also for buses. And indeed, our HyGen generator still in our facilities is supplying the gas to that location. And for future fueling station, it really depends on the economics. Of course, if you have certain capacities for the fueling stations, you have different options. If you have lower capacities for a pilot project, etc., it might be more effective to truck in the hydrogen gas. If you have larger capacities, you can choose for the on-site generation, and after that you can choose for a combination. So it's really depending on the scale of the station and the amount of vehicles that are prospected to be there to design such a station.
It's good to hear that. And probably you may know that the Hyundai Motors has exported this hydrogen trucks to Europe, and the first fleet is now operational, I think, in Switzerland. Maybe.
Yes.
Yeah.
Hopefully,
Switzerland.
Yeah, hopefully they will pass by Arnhem and they can use your
fuel it up there.
Fuel it up there. Yeah.
If it happens, we will sure to capture that on camera. Yeah.
Yeah. Also, I was
About-
happy to
about-
see those Nexos there as well. Yeah. Willem?
About thinking, we also, you hear me or not?
Yeah, I can hear you. Yeah.
Okay. On tanking, we also do in Northern Netherlands in the Heaven project one interesting test. That is high-speed tanking on trucks. Also at the car, you have now the 1.7 kilograms a minute. And this will go to 10 kilogram a minute and a 700 bar.
Okay.
So that's a pilot also that we can really have a big truck in 10 minutes full.
Okay. That will be very interesting technology for Korean the operation company that recently launched. So if you can send me some information, I can also relay that information to the possible Korean customers.
I can do it.
Okay.
Involved there.
Yeah. And I just received the also question for electrolyzer manufacturer. I think this is Elchemtech once again.
Maybe we also have HyGear there.
Oh yeah. But I forgot about the.
We're a distributor for the alkaline electrolyzers, so we can offer both options to customers. But we currently do not manufacture themselves.
Okay.
Okay. So for large scale electrolysis in range of 100 megawatt, do you foresee for the future that these systems will be built by one large electrolyzer or several small ones connected in series?
Well, I think because of the many issues there, I think everything will be a modularized plant. It won't be just a 100 megawatt stack. It will be like, for example, 5 megawatt stack in parallel or 2 megawatt stack in parallel. I think that would be it was more likely to do that because one of the issues would be the maintenance. If you have a 100 megawatt electrolyzer, if you want to have a single cells have a problem, and if you want to replace that, you need to, how should I say, split out the whole 1 megawatt system. So there will be a big issue there. So it will be more likely to go as a modularized plants.
Yeah. For operational point of view, that's much less risky.
Yeah, but what you will see is that at the balance of plants, you can make a lot of cost saving. I mean, now you have for every 1 megawatt, you have a cleaning step, and you need a pressure pressure measurement, a level measurement. And when you have 10 units, you have needed 10 times. When you say, okay, we just prepare on one place the water for well, you get a kind of saving. Also, it will be modular, but also it will be grower. I mean, now you have 1 megawatt, and maybe you will buy 10 to go to 10, but when you go to 100, you will have more 10 or 20 megawatt units, and then you buy 5 of them to go up. That will be the road to move.
Yeah. Okay, I think I have some few other questions by myself. Yeah. For Stork, sorry.
Yeah.
So you are also working on this hydrogen boiler and burner, and here in Korea, the hydrogen is considered as mostly the energy source to convert to electricity when you use it as a stationary use or mobility use. And I noticed that there are several projects in the Netherlands. They use hydrogen just as the for burners and boilers. Is there what are the demands in the Netherlands? Why the Dutch customers need these burners and boilers to be fed with a hydrogen? Do they just convert these natural gas burners and boilers to hydrogen? And can you explain more about this? How the Netherlands market is?
Yeah, I do it first for the housing market and then for the industrial market.
Okay.
For the houses market, we have more than 7 million houses who use natural gas in there as heating. Also, we asked my team to develop a hydrogen burner with the same capacity, also this 28 kilowatt, the same size, the same pressure than the old one. Also, that could be really a one-on-one replacement. And they did develop things, and the density of hydrogen is different than natural gas. That means you need other kind of burner, you need other kind of fan. You also you don't see the flame, also you need a different kind of sensor. But this will be maybe 10-15% more expensive than a current a boiler. A full cell is another option, but it's much more expensive in use. It's maybe better used for bigger kind of houses. I mean, now I don't have the price in Korea, but let's say we target about €2,800 for these hydrogen burners, and the price on fuel cells will around €50,000. Also, especially in houses who are not so well isolated, is a very good solution. Also, you have the big cities, you can use heat nets. New buildings, you can very using heat pumps. But in the range between, it is burned very well. Then the second stage is industrial burners. When you get really want high temperatures, you cannot get there on electricity. By hydrogen burners, you can go up to 3,000 degrees. Also, that's not a temperature range that you can get with an electrical burners. So that's about the two different approaches.
So the main driver for the hydrogen burner in industry is the industry that needs these high temperatures.
High temperatures, that's the main reason there, yeah.
Is there a specific industry that you can maybe example? Is there example?
Now let's say in the kind of glass industry, that is really need high temperatures there.
Okay.
They using at the moment very large amounts of natural gas. You cannot replace it by also something in the steel industry. This kind of industry you have to think on.
Okay.
But also in the UK, they planned a very big project on hydrogen burners. At the time we started, it was 700,000. Now they want to go to 3.2 million houses on also the things that we develop. They also go partly to UK. Then there's a very big market. Only in Holland we are running a little bit ahead in execution. Also, this will just bring in the UK project.
Okay, thank you. And if there is no more questions, then I can also brief you about the today's announcement from the Korean government. This is also very interesting development, because I see in July, and there was the first this hydrogen economy committee, where we had this first exhibition of this high speed mobility show, and there was a second one just this morning. With the Prime Minister and the Chairman of Hyundai Motors and Kogas and all the other the top management of these hydrogen-related companies in Korea. And there was some important announcement. Maybe it's good to know. The Korean government decided to mandate hydrogen proportion in electricity power mix to reach 8 gigawatt from 2020. So in Korea, they use this RPS system. Standard for the utility companies to have a renewable portion of their power generation. Now they are mandating hydrogen in certain portions. So all these utility companies have to invest in these kind of hydrogen fuel cell plants. And coal gas can directly provide natural gas to hydrogen producers, and price will be favored. It is expected 43% lower price from now. And tax reduction for hydrogen production using natural gas on purpose of the vehicle refueling. And a new, as I mentioned, a new special purpose company called HyGear is for commercial vehicle refueling station, will be established with €250 million supported from the government and also the private sectors. So as you can see, there is a clear government incentives are now placed basically on the stationary use and the mobility use, but they all care about the total life cycle of hydrogen, basically from the production, how the price will be reasonable for hydrogen car owners to fuel it. So that was something that I want to also share to you because today it was just announced today. And let's see. I think we still don't have any further question.
One of my questions that I did the European investigation about entire hydrogen, and one is mobility. And one of the things that I see, we have all these nice countries. They have a very high number. Also, your country, 200,000 fuel cell cars in 2030, I believe. But when you look to your Toyota or to Hyundai, I don't see these very large numbers in production. When you just compare to Tesla, they produce 500,000 cars a year.
Yeah.
I don't see. I mean, Toyota go from 3,000 to 330,000. Hyundai is running a little bit ahead, but they are not have the volumes there. You see more companies going in this market or a faster ramp up.
Yeah. What I heard from the previous invited speakers was that basically Korea and Japan is the only two countries who are producing these commercial fuel cell cars, and Mercedes is going to launch their fuel cell car soon. So Germany will be the third country. You know, I used to work for the other company before when I joined the embassy, and I met a lot of these automotive car companies because the company I used to work for they were working on the PEM fuel cell, and car companies back then I think was like early 2010. Back then they were hesitant which one is is battery electric car or fuel cell with the future. But then it comes with the boom of these IT devices. So all these battery manufacturers, their supply chain become stronger because they have this market already built with the lithium-ion battery. So I think for OEMs, it was right thing that because they need to have a good sustainable supply of this battery, because that's 40% of the car cost, the total vehicle cost, and that's the really vital portion. And on the other hand, the fuel cell, I think they didn't reach these sort of scale of economy from the material to the system yet to be really for OEM the car companies to really ramp up. I think that's why for Tesla they decide to have this gigafactory themselves, and they want to ramp up with the battery. But before that, Panasonic, LG Chem, they had this capacity. But for fuel cell, I think that still hasn't come yet. So that's why I think is lagging some things. And I watched the few presentation from Hyundai Motors last few months, and that's why they are also interested in to use their PEM fuel cell to other applications, and they are also willing to share this technology to other vehicle companies or even to competitors to use the fuel cell. Then they think that this will generate the vehicle volume for the market. Yeah. So like a tram run by the fuel cell. Also, Hyundai Motors is also working. I think Hyundai Mobis is making the fuel cell stack, and they're providing this PEM fuel cell with the Doosan's PAFC to have this power plant in Ulsan. So PAFC will generally produce this baseline power, and the PEM will do the match the fluctuation, so that they made sort of joint venture together. So this kind of thing is the Hyundai is working on. They want to diversify their market so that this could make them to reach the scale of economy.
Okay.
So I think that's the. We don't. If you don't have further question, maybe we can call it this the end, and we can probably do the. I can also explain a little bit about the other programs later next week. This might be the webinar for this week is come to the end, but this is not over because as you can see, the banner is until 2nd of October. So next week we have some different modules. I want to explain about the B2 match, which is online matchmaking. So if you're not registered, please sign and make the meeting request and accept one if you have received. And there will be a hydrogen exhibition at COEX from next Wednesday to Friday. The embassy will present the Dutch companies. So also for the Dutch company, if you have some promotional materials or things that you want to promote there, we can always represent you here in Korea. 저희 대사관은 다음 주 수요일에서 금요일 사이 코엑스 홀 A에 있을 H2 월드에 부스 참가할 예정입니다. 네덜란드 수소기업 기관의 협력에 관심 있으신 분들은 저희를 방문해 주시면 감사하겠습니다. Okay, so this is it for the webinar this week. Thank you very much for presenters, viewers for today, and for the last 2 days. And I'd like to thank also all the staff that supporting us today. And so please note that this is not over, so we can still do the matchmaking and meet at the exhibition. Thank you all for watching and hope to see you soon.
Thank you. Bye-bye.
Thank you very much.
Bye.
Bye-bye.
Bye.
Bye.
감사합니다. 감사합니다.
감사합니다.